Well, hello. We're going to go through the quiz on the math of chemical formula. Some of you did a great job on it, but there were too many of you that were missing some parts. So there were three different quizzes. One was first hour, third hour, and seventh hour, and I'll go through each of these. So I'm going to go through the first hour first, and I'll probably uh, make that one video, and then do a separate video for third hour and a separate one for seventh hour. So here could have been your first question. What is the mass of 0.0250 moles of magnesium phosphate? And then it gave you all this information down here about magnesium phosphate. That wasn't really an important bit of information at all. You didn't need any of that stuff. Now, what's in blue, I added because that's usually useful when you're doing these mole type calculations. So in the formula, Mg3PO42, you should be able to tell me there are 3 magnesium, there are 2 of everything in the parentheses, so that means there's 2 phosphorus, and there must be 8 total oxygen. Now you have to look up the molar mass of each of these from the periodic table. Magnesium weighs approximately 24 grams per mole. 3 times 24 is 72 grams. Phosphorus weighs approximately 31 grams per mole. 2 times 31 is 62 grams, and each oxygen weighs approximately 16 grams per mole. 8 times 16 is 128 grams. So if you add those all up, you should get 262 grams, the number we put down here. Okay, that was the first one. Let's go to the second one. Now, this was definitely a little bit of a tricky question. You had to do quite a bit of work. Which has more atoms, 40 grams of water or 250 grams of chlorine gas? Well, you have to remember that chlorine is a diatomic Cl2. And water, of course, has the formula H2O. Now, we want to know how many atoms are in each. Well, in water, there's an H, an O, and an H. So there are 3 atoms per 1 molecule of water. Now, chlorine, on the other hand, is diatomic, so it looks like this. So there are 2 chlorine atoms in 1 molecule of chlorine. So that's the first part. Well, now we can set it up using dimensional analysis. So we might want to know how many atoms are there in 40 grams of water. Now, our first step is to figure out, well, let's do it this way. Let's say 1 mole of water is equal to 6.02 times 10 to the 23rd molecules of water, which equals the molar mass, oxygen 16, each hydrogen is 1, 18 grams. Now, what I'm going to do is I'm looking for a conversion, and that conversion needs to relate between grams and atoms. Well, I don't have that directly, but I do have grams to molecules, and I'm going to use that conversion. So we're going to put that in there. Every 18 grams of water is the same as 1 mole of water, and we know 1 mole of water is 6.02 times 10 to the 23rd molecules of water. And grams of water cancel like that. Now, some of you stopped there. That was a little bit early because the unit doesn't match. We need to remember that in every 1 molecule of water, there's 3 atoms, and we're trying to get 2 atoms. So we have to add one more step. 1 molecule of water is composed of 3 atoms. And if you work that out, you're going to get this number down here, 4.01 times 10 to the 24th atoms in 40 grams of water. Now, let's do the same thing. This time, we're going to use the chlorine gas. So I'm going to write under here again, and what I know is 1 mole of chlorine gas equals 6.02 times 10 to the 23rd molecules of chlorine gas. And in this case, I need to figure out what it weighs. Well, it weighs 71 grams. Cl by itself is 35.5. but you have 2 Cls times 35.5 grams. That's the 71 grams. So let's figure this out. How many atoms are there in 250 grams of chlorine gas? So our first step, we're going to use that same looking conversion. 71 grams of chlorine, that's the molar mass, is equal to 6.02 times 10 to the 23rd molecules of chlorine. And grams of chlorine cancel, just like that. Now, we're not quite done. Have to remember, there are 2 chlorine atoms for every 1 molecule of chlorine. So we have to put that in here. Every 1 molecule of chlorine is composed of 2 atoms. Molecules of chlorine cancel, and when you do that math, you get this number down here, 4.24 times 10 to the 24th atoms. Therefore, the chlorine has more atoms. Now, you had to have work. If you just put an answer down and didn't support that, you were not going to get credit. All right, this one's a little bit more straightforward. We want to figure out what volume 16.3 grams of sulfur dioxide gas would be at STP. Now, we're going to use the little information that I wrote down here, because that should be kind of in your memory banks. We know that 1 mole of sulfur dioxide will equal, well, I better figure that out. I have 1 sulfur that weighs 32 grams, and I have 2 oxygens, each that weigh 16 grams, so that SO2 has a molar mass of 64 grams. And I also know that 1 mole of any gas at STP occupies 22.4 liters. For this question, I'm not asked about particles, so I'm not even going to worry about that. So now I can set it up. I'm looking for what volume of sulfur dioxide gas is equal to, in this case, 16.3 grams of sulfur dioxide. Now I'm looking for a conversion, and this particular conversion relates between grams and liters. And I have one right here. 22.4 liters is 64 grams. So I'm going to go ahead and put that in here, making sure my units cancel out. Every 64 grams of SO2 will occupy a volume of 22.4 liters. Grams cancel. I type that in my calculator, and you will get 5.7 liters of SO2. All right, let's keep moving. How about this one? How many formula units? Well, the term formula units is basically particles. How many of those are we going to have? So we can set this up. How many formula units? I'm not going to abbreviate that FU. That wouldn't be appropriate. So I'll write out formula units of calcium chloride are in 2.50 moles of calcium chloride. So I know that for every 1 mole of calcium chloride, there are 6.02 times 10 to the 23rd molecules. That's my conversion. So let's go ahead and just put that directly in. In the denominator, 1 mole of calcium chloride is equal to 6.02 times 10 to the 23rd. Now, the formula unit is what these particles are talking about, formula units. Moles cancel. 2.5 times Avogadro's number will give me my answer at the bottom, 1.51 times 10 to the 24th formula units of calcium chloride. All right, we're doing really good. We got 4 of these guys done. We got 4 to go. What is the percent composition in silver nitrate? Now, you need to remember the formula. Percent is the part divided by the whole. Well, we need to figure out what the whole AgNO3 weighs. Well, there's 1 silver, And looking at the periodic table, that weighs about 108 grams per mole. There is one nitrogen in that formula. Each nitrogen weighs 14 grams per mole. And there are 3 oxygens, and they each weigh 16 grams per mole. 3 times 16 is 48. So silver nitrate's molar mass comes out to be 170 grams. So if I want to find the percent that is silver, it's the part that's silver, 108 grams, divided by the whole, 170, times 100, add a percent. And that comes out to be 63.5%. Well, I can do the same thing for nitrogen. The percent nitrogen will be the part that's nitrogen, 14 grams divided by the whole, 170 grams, times 100, and that equals 8.2% nitrogen. Now, if you add those two up, the remaining percent must be 28 to get to oxygen. I could have easily just said percent oxygen is 48 grams divided by the whole, 170 grams times 100, add my percent sign, and I get my 28%. All right, then we came to this guy. This was a little bit tricky. I have to admit that. In order to get empirical formula, there's our steps: percent to grams, grams to moles, and mole divided by mole. So my first step would be to say, well, I have 37.51 grams of carbon. I have 4.20 grams of hydrogen, and I have 58.29 grams of oxygen. Convert each of these to moles. So carbon weighs 12 grams per 1 mole. On my calculator, that works out to 3.126 moles of carbon. Hydrogen, of course, weighs 1 gram per 1 mole. That one's easy to do. 4.20 moles of hydrogen. And oxygen weighs 16 grams per 1 mole. 58.29 divided by 16 comes out to 3.643. 3.643 moles of oxygen. Now here's where it gets a little bit hairy for us. The next step says divide by the smaller number of moles. Well, in this case, we're going to divide each by 3.126 moles. Now this first one comes out to be 1 carbon. Now the second one comes out to be, unfortunately, 1.34 hydrogen, and the last one comes out to be 1.152 oxygen. Now that's a head scratcher, isn't it? Now I said if they come out to be a half or a 0.33, half you double, 0.33 you triple. So let's just for fun see what happens if we do this. Let's multiply each of these times 3. This comes out to be 3 carbons, this comes out to be 4 hydrogens, and this comes out to be 3.5 oxygen. Now see, normally it would be done there, and that was the extra beauty of this question. You then had to double each of these to get whole numbers. So you end up with 6 carbons, 8 hydrogens, and 7 oxygen. And when you put that together, you get the formula C6H8O7, which is citric acid's formula. That was a tough one. All right, 2 to go. Let's try this one. This one says the decomposition of a substance produces 97.9 liters of O2. You're supposed to remember a decimeter cubed and a liter are the same thing. So we have 97.9, I'm going to call that liters of O2. And I have 49.0 liters of chlorine gas. Now, if I want to find an empirical formula, I go percent to gram, grams to moles. Well, I'm at liters, so I need to get those things into moles. So you had to kind of apply that information to kind of see how could I get there. So you should know that every 22.4 liters of any gas is 1 mole of that gas. Well, this comes out to be 4.37 moles of O2. And for the chlorine, it's still at STP, so 22.4 liters of chlorine gas would be 1 mole of chlorine gas. 49 divided by 22.4 is 2.18 moles of chlorine. Now you have moles, divide by the smaller number of moles. In this case, let's divide both by 2.18 moles. This comes out to be 2, and this comes out to be 1. And so you end up getting a 2-to-1 ratio of chlorine to oxygen. So in essence, we have 2 oxygens and 1 chlorine. So putting that together, we'll get the formula ClO2. Okay, ClO2. Now, some of us might have been confused because it says oxygen gas and chlorine gas. And as a gas, they are O2 and Cl2. But as a compound, they can be any combination they want. Again, a little bit tricky. I wasn't really planning to make it that tricky. I was just picking questions from the textbook, an old textbook I had, and that's what came up. Sometimes you win, sometimes you lose a little bit. All right, let's try the last question. Sucrose is ordinary table sugar, and it has a molar mass of 342 and an empirical formula of this. What is its molecular formula? Well, you should know that in order to go from an empirical to a molecular formula, they are simply going to be some multiplier of times 1, times 2, times 3, some whole number. So I just need to figure out what does my empirical formula, C12H22O11, what does this weigh? So I have 12 carbons. Carbon each weighs 12 grams, so that's 144 grams. Of course, I have 22 hydrogens. They each weigh 1 gram, so that's 22 grams. And I have 11 oxygens, each that weigh 16 grams. 11 times 16 is 176. So that my sucrose, at least this empirical formula, weighs 342 grams. Well, that is identical to the molar mass. And because those are identical, that means the empirical formula and the molecular formula are both C12H22O11. I hope this helped you a little bit. I'm going to put on here as a separate video the quiz that I gave in 3rd hour as well as 7th hour. Feel free to look through those if you want for practice as well. All right, thanks for taking a look at these. Hopefully this helped you understand it just a little bit more.